Dealing here with aldehydes reacting with KCN and dilute acid, so we can see what the reactants and the products are, and our first question is to give the Iupac name of what is provided. I think it's always worth, if you have the time, drawing these out so you can very clearly see them. And what you can see where I've done that here is I'm able to see precisely what's on each carbon. I'm able to number them to give me the lowest possible numbers, also taking into account the priority groups. And from there, we can start to build the name up. The fact that it's a CN tells us that it's a nitrile, and it's actually a hexane nitrile. Again, remembering that the carbon within the CN is a part of the carbon chain. Now, coming off it is an alcohol, but we can't have ol as a suffix if we've got nitrile as a suffix. So we have to use the prefix, which is hydroxy. It's in the 2 position, so it's 2-hydroxyhexane nitrile. And then we have to think about how we might distinguish between 2 separate samples of stereoisomers of the product. And what we're looking at here are optical isomers. And when you have an optical isomer, it's a standard 2-mark question. First of all, we've got to remember that we use plain polarized light. And secondly, we need to remember that they will rotate them in opposite directions. Now, I've added here in a different colour that you'll often talk about those in terms of one of them will rotate it clockwise, the other will rotate it anti-clockwise. Now we have to explain why the reaction produces a racemic mixture. And again, I've started off here with not my official answer, but some help that's going to get us to the answer. Because if I draw out my carbonyl, I can see that my CN- could attack on the left-hand side, or it could attack on the right-hand side. And if it did attack on either of those sides, it's going to mean the CN is in a different position relative to the other components. So they're my 2 options. The carbonyl group is planar, that gets you a mark. It can be attacked by the CN- from either side, that gets you the 2nd mark. And for the 3rd mark, you simply have to say that it's equally likely to attack on either side. And finally, we have got here an aldehyde. We're reacting with KCN and dilute acid to form a compound that doesn't show stereoisomerism. So your job here is to draw that structure out and explain why it doesn't show stereoisomerism. Well, when you do this, you're thinking of an isomer that's going to prevent us having those different stereoisomers. So my structural isomer is, in this case, a functional group isomer. I'm going from pentanal to pentan 3-one, and that pentan 3-one has a level of symmetry. Now, when you actually work through to the product that you're going to get with the CN and the OH, that's the structure that you can see. We're going to get my CN and my OH both coming off that middle carbon, the 3rd carbon. So when you then start to find or try to find chiral centers, you can see going from left to right that on the first one we've got 3 H's, it's not a chiral center. The second one has got 2 H's, not a chiral center. The 3rd one has got an OH, a CN, but it's then got 2 ethyl groups, not a chiral center. My carbon 4th along, no chiral center, 2 H's, and 3 H's on the last means not a chiral center there either.